Hi, I'm going to show how I replace these aluminum electrolytic surface mount capacitors on my Mac logic boards. Now, I'm not saying that my way's the only way to do it or the best way to do it, and there's probably going to be a lot of people that watch this and think I'm nuts, but I've found that it works well, and I've never damaged anything doing this method, whereas I have damaged it using hot air. So here's how I remove caps, and this is going to be performed on a Quadra 605 or LC 475 logic board. So you need two things. You need needle nose pliers and you need tweezers to remove them. So what I'm going to do here is actually physically rotate the capacitor and break it off. And that sounds barbaric, but the thing is, the capacitors break off like at the little thin leads going into the can much earlier than it's going to actually damage any of the pads, at least in my experience. And if you've got a board that does have really bad pad damage, then this may not be such a great idea. But if you just got a little bit of leakage, it seems to work pretty well for me. So I'm going to start by showing what I do here. So what I do is I put tweezers down and I push down. And really what I'm trying to do here is just really make sure that I'm not lifting up lifting up the cap off the pads, because lifting it up is going to make it really easy to actually damage something. So you want to be pushing down while you're doing this. So I'm pushing down with this, trying to really hard not to make sure that I'm not lifting, and also trying to hold that this black base of the cap right here in place. So I'm pushing down, and what I'm going to do here is just grip the can with, let's see here, I gotta get room to do this. Grip it with the pliers and just twist it. Now this sounds crazy, but what'll happen here is it'll break off. There, I just heard it break. And I'm going to turn this upside down so you all can see. So what's happened here is it's actually broken off at these little thin leads here. And if we see what's left here, the pads are perfectly fine and they're still intact. So that'll be really easy to remove with a soldering iron. Whereas like with the heat, I would have had to worry about any plastic nearby. So let's do another one. So I'm pushing down with the tweezers while I rotate. And I'm also pushing down as I rotate here too. I just really want to make sure I'm not lifting, because lifting would be bad. And there we go, got another one. And yeah, you can see it's just breaking off right there at that lead. I think this will be a good angle for this. Okay, you can tell it's loose and it's off. Sometimes, like in this case, the black base won't come off. So I'll come back to that one in just a minute. Here's the next one. Again, I'm just pushing straight down and it's off. And where this method works really well is in these tight places, like these two right here. So these are right next to a whole bunch of plastic stuff. So like there's some people that are just dead set on you have to heat it up and remove it properly. I don't see the value in doing that here, where you're going to melt all this plastic. I mean, yes, you can cover it with Kapton tape and aluminum tape, But why don't you just rotate it off like I do? Obviously, it's one of those things where everybody has their own way of doing it, and I'm not going to fault anybody who does it a different way. It's just so much easier, especially when there's all this plastic right here, to just mechanically twist it off. And my line of thinking is if this twisting is actually going to damage the pad's already in pretty bad shape anyway. So in my mind, like, there's a good chance that the heat would damage it too. Okay, is this coming off yet? There we go. It is off. So like, if the twist method's hard enough, I just can't imagine heat, like what you're gonna have to do if you're going to want to use heat instead. I think on this one I might need to grab from above. We'll see. Yeah, that's working pretty well. Again, pushing down while I twist. There. Actually, having this camera here is kind of interfering with my positioning. So I wouldn't normally do this while I'm recording. Okay, we'll just go this. We'll go like this. Some people like to wiggle it back and forth. I think that probably works fine too. This is just the way that I've always liked to do it, to make sure that everything's all detached. Okay. Once again, just rotating the cap. Pushing down. And it's off. So we'll do this one next. And yeah, like, I would probably only do this on a board that hasn't been recapped before. Because if it has, and you don't know the history of it, somebody could have really damaged some of the pads with heat when they soldered the new ones on, or even when they removed the old ones. And that's going to make it much more likely to damage. But when these are stock machines that have never had their caps touched before, I have a 100% success rate. I've never actually recapped somebody's board that has already been recapped once either. So I just have a 100% success rate with this method regardless. But like, I would be afraid to try this if somebody else had already recapped it. Okay, the last cap here, this one should be easy because I have plenty of room to work with. And you can just kind of hear and feel the lead break off when you're twisting it. Here we go. Earlier I did kind of lie because there is a third part that you'll need if the bases won't come off like this, and that is side cutters. So these are kind of large. I'd probably recommend smaller ones if you were going to do this, but this is all I've got. So let's fix some of these. Basically what you have to do now is just like cut off. So push down, make sure you're not yanking up, but dig right in there and cut off as much of the lead as you can. Basically get it to the point that there is no thick lead sticking out anymore. And then once you've done that, which I guess I haven't done yet because it's not moving. Let's see. There we go. I think I got it now. So once you've done that, it just lifts right off. Yeah. So right here, I'm just gonna reach right in here, pushing down again, like you're really wanting to make sure you're not doing any upward force, because upward force is your enemy right here. You just want to be pushing down. You're gonna make it much less likely to damage anything. See, this still doesn't really want to move. I think I have just a little bit more to dig in here and cut. There. It can get a little tricky to reach in here sometimes. So hopefully this won't go too bad. Looks like that little lead had already broken off. Yeah, you're just reaching in there, cutting off what's left of the lead, and then you should know when you've done it because this will just pop right up. This guy might be a little hard to reach, but I do need to cut off this part that's sticking up, unless I can just lift it off. So let me see if I can just lift it off with basically no force. Just will it come off on its own without any persuading? And it doesn't look like it wants to. I think I really do need to cut that. So we'll just see if we can squeeze this in here. There, it came off with just as soon as I cut just a little bit extra off of there. Again, I'm pushing down, not lifting until I know it's been cut, because otherwise I'm going to be lifting that pad right off with it. So here's one. And I think what you'll find a lot of the times is as you start cutting it, this little paddle, this little base will basically try to lift itself off right when you're doing that. I like to cut staying aligned with the pads here. So like doing it this way if the pads are running this way. So that's why I'm rotating it like this. Okay, I don't know. Okay, that is ready to come off. Good. Okay. That one came off. And what I believe is the final one here is this guy right here. This one may be kind of hard to reach. I may have to actually go against my normal rule here and cut against the grain here. I really don't want to. I'll probably do it as close as I can to cutting with the grain. I hope you can see this. Yeah, we'll just go ahead and do it this way and hope for the best. It looks like it's about ready to come off. Just need to push in a little bit more. There we go. And that one's off. So I think there are 11 capacitors on here. All 11 have been removed. I didn't lift any pads. Okay, so the next thing that I'm gonna do is clean off all of these pads. And so each one of these pads is going to have a little piece of the capacitor leg still on it. So I'm going to use my soldering iron here. I have a chisel tip on it right now, and I'm gonna have it heated to about 325 degrees Celsius or so. It doesn't have to be very hot. So what I'm gonna do is heat up these pads just enough to slide the remainder of the capacitor legs off of it. And then I will use wick to suck off what's left. So we should be left with fresh pads. So we'll add some more solder. It also has a little bit of flux in it, which helps with heating. There we go. And I don't know if you can tell, but the what's left over from that pad is now stuck to my iron. So I'm just gonna stick it in here in my little solder. I don't know really what you would call this thing, like a dry sponge, and just get it off of there. So we're gonna do the same thing here. Just put a little bit of extra solder there, and we're just gonna slide that old leg right off. And yeah, you can really see it attached to my iron there. So I've got the old, like what's left over from those legs off of these two pads. And I'm just kind of sliding my iron along the pads just to kind of clean them up. I will do use the wick after this, but I just want to do that with every pad now. And you should be able to tell, because what'll happen is once you get it off, you should find that it's really much easier to slide your iron across the pads. Got that one off. But even then, it's not always easy to tell if you've actually removed the little leg. I think that's looking pretty good. And it's kind of scary because when you first do this, you almost wonder, holy crap, did I just take the whole pad with me? But no, you didn't take the whole pad with you. You just took that little leg that was still soldered in there. And this fresh solder is just helping everything flow nicely. Yeah, if you're looking at that, you might think, oh, geez, he just lifted the pad, but no, I didn't. That is just what's left from the capacitor. There we go. Add just a little extra solder here and make sure everything's looking good. And yeah, it honestly scares me a little bit every time I do this too, because I think, oh no, what have I done? I've lifted the pad. But no, I haven't. And believe me, I have lifted pads in the past, not with this technique, but with previous techniques that I used to use. Just like trying to take it off, like rocking it with the soldering iron back and forth. And so far, this has been my favorite method. Let's see, this one, you could tell that this cap had leaked a little bit because it's struggling to take solder just a little bit. But once you get it to take, it's good. Okay, there we go. That one's... Let's get that off of there. Looks good. See, there's that little leftover pad right there. I mean, leftover leg. See, what I love about this technique is I'm not having to apply a whole bunch of heat all over the board in that section. Like, all I have to do is heat up the two pads. And I mean, heat is dangerous to these boards. I mean, you've got some thermal expansion that might go on, like you might warp the board, which I've definitely warped boards with hot air in the past. Not a classic board, but like just random boards when I've been learning how to do this. Okay, now we're gonna do the fun one here. These two pads definitely had leakage underneath of them. You can see they're not that pretty, and I'm probably gonna have to do some cleanup on that section of the board. I'm gonna start by just trying to get the existing gunk off of here. And basically, yeah, I'm just heating it up. At this point, I'm just trying to get anything to like accept the solder, and I'm getting that fishy smell, so definitely capacitor leakage. But yeah, I'm just trying to get these pads to accept the solder I'm putting onto it. I'll worry about making sure that I've gotten the old leads off after that. I think they may be coming right off though. But you definitely need fresh solder and or flux in this part of the process. Okay. This one's really unhappy right here. Yeah, you don't want to be too rough with it because you don't want to damage these pads, but they shouldn't, like, unless it's been like that for a long time, you should be able to get the crap off of it and just be left with a nice pad underneath. Yeah, these are feeling pretty nice. Okay, so that, I believe I've gotten the leads off of all of the pads here. The next step is to actually use the wick to get all of the gunk off of there. Like, this will take all of the new solder I put on and any old solder that's still there, and I should just end up with fresh little shiny pads underneath. They tell you not to like push down while you're using the wick, and you really shouldn't push down hard, but in this case you're also kind of trying to clean the pad at the same time. So I kind of go against the conventional wisdom here a little bit, and I do kind of like very lightly still, but I am scrubbing a little bit while I do this to try to really clean these pads off. So this is pretty difficult for me to do while filming, so you're gonna have to bear with me if I screw this up. But yeah, let's see if I can do this. Yeah, these pads are not happy. I'm still getting some of that fishy smell too. And yeah, you really don't want to overdo it here, because you can lift the pads if you're too overboard with the heat. I'm pretty happy with how those two look now. They're looking pretty flat. They don't look super shiny in the camera view, but they do in real life. So I think I've done a pretty good job on them. And like, I'm definitely gonna have to clean up the surrounding area as well after I get all these pads scrubbed off. There, I'm very happy with how those two look now. Okay, so wick does have flux in it. And sometimes you'll see this like darker crud left over after you use the wick. At least this wick does that. And it's okay, it'll clean right off with the alcohol. But yeah, I just want to mention that so you don't freak out if it happens to you. It's just the flux. Okay, let's get some more pads cleaned off here. It's looking pretty good right there. Take just a little bit more off. Okay. Pretty happy with those two. I should have started over on the right here, because then I kind of have a natural motion from right to left as I'm removing all of this excess solder. That's okay. There's no one right way to do this. It's just whatever you prefer. Yeah, and those pads are looking pretty darn good now. And yeah, you can get quite a bit of use out of this wick. Like I'm even probably cutting it up a little bit too soon, if I'm being totally honest. Like the wick is fairly reusable. I mean, it has a lot of capacity to pull solder in. I think there's still like a little bump right here that I'd like to get off of this pad. And yes, I probably should be tinning my iron maybe a little bit more, but I don't like this constant pattern of having to tin it and then just wick it right back and tin it. So I kind of like to do all my wicking at the same time, and then I'll do a massive cleaning job on the tip at the very end. There, that looks really good. It's gonna be kind of hard to see. I can't really adjust my camera in a great position for this one, so bear with me here. Yeah, that looks pretty good. Okay. This one feels like there's a little bit extra on the edge there. Yeah. I think that looks great. Okay, so now at this point, I'm all ready to use Q-tips and 99% isopropyl alcohol to really clean up these pads and the area of the board. So I just put some alcohol on there and really just scrub away, and you'll see it's getting dirty. So I'll probably switch to the other side here, and basically I'm just trying to do this until I'm not getting any like yellowy stuff. Part of what I'm cleaning off here is also the flux from my fresh solder, as well as from the wick, the solder wick. Okay, let's do these two. And if you've wicked the solder off well enough here, you should be able to notice that as you're doing this, you can just slide the Q-tip right along the pad without feeling like you're hitting any bumps along the way. If you're feeling bumps while you do this, it means you haven't wicked all the solder off, and these little fibers on the Q-tips are getting hooked on it. So that's just a way to kind of double check your work. And the other thing you're really doing here is kind of looking in the area around each cap to see if there was any corrosion, because if you find corrosion there, it's kind of to be expected, because that's where the fluid would have leaked. We're starting to get close to the problem area of these two caps down here, so I might see a little more gunk. It's actually not looking too bad. Okay, I'll come back to those in just a minute. I just want to get these other two right here cleaned off. Okay, so these two right here are going to be interesting because there was definitely gunk on the board in this region. Well, luckily it doesn't seem to have affected this chip right here because the legs on that chip still look nice and shiny. But yeah, see, we're getting a lot of black on the Q-tip here, so I'm really gonna focus on scrubbing this area of the board around these caps. We'll look at it from a few different angles to see if there might be some nearby damage here. Let's rotate it around. Unfortunately, I can't see very well myself. This, I think it's a resistor, but I can't tell right now. It looks a little bit iffy. I think that the corrosion just got right into its solder. It might be smart to reflow the solder on it, but I'm just not going to bother right now. At the very least, I'm just going to really make sure to scrub that. What else do we have? There's a little bit of crud on these pads right here. For an unpopulated something. Maybe a diode, I can't, maybe a transistor. Yeah, so it looks like most of the crud kind of on this board restricted itself to around here and maybe a little bit over in this area, but not here. This chip is fine, even on the legs that we're facing right up against the caps. So maybe that'll, well, I don't know what that means. Maybe it has to do with how it was stored. Like maybe it was stored in a way that it was down like that. I'm not sure. That's honestly looking pretty decent. I think I'm going to clean down here a little bit. I don't know, there's a little bit of lines right in this section. I'm not sure. You know, not bad at all. So once you're happy enough with your cleanup job here, and I guess that kind of depends on your personal preferences, you're ready for the final step, which is pretty simple. It's just soldering the new caps on. Okay, and now for the main final part of this, which is just actually soldering the capacitors on. I'm going to start with these two capacitors down here that are different from the others, because all the rest of them are identical. But these two are 100 microfarad. The originals were 6.3 volts, I think, or maybe, I can't remember. It might have just said 6 volts. You can go back and probably see it on the video if you want. But I like to derate tantalums. I do use tantalum caps. This is a whole nother kind of preference thing, just like the removal method. I like tantalum caps. I have heard they're more likely to blow up. I've never had that happen to me. But that's what I've heard. And so they look, I'll drop one of them here so you can see. They look like this. And one thing to keep in mind is this bar actually marks the positive side of the cap rather than the negative side, like the original caps. So you want that bar going the same direction as the plus sign on the logic board. So like right here, this little plus means that this cap, the plus should be going in, and this plus goes with this one. So yes, in this case, when I solder these two in, I'll want to set them like that. So let's go ahead and get started here. Now, one thing that you want to think about here when you solder these on is be strategic about how you want to place them. You don't want to get yourself in a situation where you're making your soldering job harder just because you soldered them in the wrong order and it's really hard to reach the pins. So I think when I have them like this, it's going to be easier for me, which may sound kind of counterintuitive, but I think it's going to be easier for me if I solder this one in first, because then I'll have all this room right here for my iron for the second cap. And the only really difficult part will be squeezing my iron in here to solder this after everything's all in there. So let's go ahead and do this. The tip that I like to use on my iron for this is a Hakko BR02 tip. It's kind of bent like this, and it just makes it easy to get into tight situations. Okay, so I like to use quite thin solder when I'm doing this, and here's kind of my overall process. First of all, I'm going to put fresh solder on one of the pads, and this is the pad that I'm going to be targeting. It'll be the first pad that I solder. So I like to put just a thin layer of solder back on there. I'm going to do that on both of these. And they're all clean now, so they should easily take the solder. If they're not, then you might want to try cleaning them a little bit more. Okay, so then the next thing I'm going to do is push, like heat up the pad again here and push the cap into place. And what you're really trying to do here is make sure you push it far enough that you're giving yourself enough room on the other side to solder it down. And after you do that, a really good idea is to push down on the cap and reheat it, just to make sure you've really got it flat against the board. Okay, and then you're just going to go over to the other side here. This is really hard to see. So I apologize for the lighting here, but the other part of this is I'm going to put some solder here and just solder that down, and you really do want to make sure that this is flat against the board. You shouldn't need a whole lot of solder. And one thing that I want to point out is I see a lot of people just dousing the board with flux when they do this. And you really don't need flux, because there's flux in the solder, in this solder wire right here. So, I mean, it doesn't hurt anything. It's just kind of overkill, I guess would be the word that I would use. And what I really like about this iron tip is it lets me get into tight spaces, but it still has a lot of thermal mass. Okay, so here we go. Now we're going to do this cap. Okay, I'm going to push it down. See how it kind of popped into place when I held it down there? That's because when I first placed it, it wasn't aligned properly. And now we're just going to get a little bit of solder down here and really try to make sure that other pad's soldered down. And yeah, I don't like going overboard with the flux if I don't have to, because it's right there in the solder wire. And that's, I think, pretty good. Honestly, you can probably see better than I can right now because I don't have my eye loop. And normally I'd have my face closer down there checking my work. But I can definitely feel that it's soldered on both sides of both of these. So I'll probably take another look afterwards, and if I find anything that looks real suspect, I'll call it out. But those two look good, and like I'd said earlier, the plus signs need to be going toward the middle on these two. So at this point, I'm happy with those two, and now I can just do the other 9 caps. So I'm gonna get those all out and ready to go here. Okay, let's do these 2 caps next. It looks like their plus signs are both to the right, so I'm going to put a little bit of solder here. Into each of these. Okay, so I'm just going to say that it's a lot harder to do this when you're trying to record yourself. So bear with me. There, that looks pretty good. We'll do the same for this one. Now, I am not a perfectionist when it comes to positioning these things. So, if you've got the OCD about where these should sit, I'm sorry. I'm more about just getting them in. So, go ahead and solder that. Everything that I'm doing is about 3 times as hard as it would normally be, just because I'm recording and the camera's in my way. But that should do it. We'll push that down, solder it again. Just make sure these are in. I like to just kind of nudge them to really make sure that the joints look good. Let's do these. These look kind of challenging. I want solder on this pad and on this pad. The problem is that I don't have a lot of room to work with due to all of the connectors and jumpers and all that stuff in there. So as far as orientation goes, the plus goes to the inside on both of these. Yeah, this is actually kind of crowded. I think what I'm going to do is pull this jumper off. This is the jumper that decides whether it's a Quadra 605 or an LC 475. And I think maybe taking that jumper off will help me position this without feeling like I'm melting plastic. Okay. Yeah, so I'll be honest, my positioning on this one isn't the greatest. Okay, this next one hopefully won't go as bad, but we'll see. I think I just need a little more solder here, which probably adds a little more flux. But I think we'll be fine. So I try this again. This, I tell you, this video is going to make me look like I'm terrible at soldering. I'm really not that bad, I promise. I think it's the angles here that are really getting me. It's the angles combined with the fact that I'm right near a bunch of plastic. They're really making it difficult for me to do this. This may end up being a little much on the solder, but it should be in now. Okay, that looks good. I'm not proud of the positioning of that, but you know, I'm making a video here for people. Alright, let's do a few easier ones. So I'll show you what I mean here about how I think the angle was the problem. I shouldn't struggle at all putting solder on this guy. I say as I struggle. There. We'll just go ahead and put solder on this guy too. Okay. Looks like the plus sign is to the left, so I'm going to want my cap to have the bar on the left here. Like I rotated it a little bit. Since I have room, I will be a little more picky about the positioning here. Okay, that looks pretty good. And now we'll solder down the other half. Does not look like I have it yet. Normally I'd be able to have my face right up against it looking. Now what do we have here? That looks good now. And just the double check here. Yep, okay. It looks like on these, the bar is gonna go to the left on both of them. So I like to heat up like the edge of the cap while I'm doing this too, because I think it just helps everything kind of flow nicely. See, especially if you're able to get good heat contact, you really do not need all the extra flux, in my opinion. Maybe it would have made my job a little bit easier, but I don't know. I have pretty good luck without it. That looks pretty good. Okay, one last cap to install here. I'm gonna make the crowded end over here, so hopefully it'll make the last part of the soldering easy. One of the challenges with this really thin solder is sometimes it really likes to bend easily. But that should be good right there. Okay, this one's going to be interesting because the floppy port is actually kind of in the way, so I'm going to have to push it from above. So that's a fun little challenge to finish off this recapping job. And that should do it right there. That is all 11 caps installed. So now I am going to double check my work to make sure I actually got them all oriented correctly. And then I'll actually hook this thing up and try to boot it up. Okay, and now I'm back and ready to test the newly recapped logic board installed in my LC475 case. So here goes nothing. That's a really good sign. And it's not going to show anything on the display unless I power it off and back on, because that's how LC475s are if they don't have battery. So we'll flip it off and back on. And let's see if we get anything on the screen. Hey, it's working. Okay, so I didn't leave it plugged in with a SCSI to SD, so I'm going to go ahead and install that now. And then off and back on. And now we should get a display and it should boot up. And there we go. So I would say this was a successful recapping job, and yeah. There we go, it's working. So I'd say job well done. And that's the process that I follow to recap a Mac's logic board. And what a better way to end video than to shut down.